Okay, so this is part one of the video presentation about confidence intervals. We'll be using some of the concepts that we saw in the previous set of slides with regards to sampling distributions um, to see how we can actually use data from our sample to estimate features of a population. So let's just go over what we saw the last time around. Right, so in the last set of slides, we kind of mentioned that, well, the sample mean or any sample statistic, right, describes our specific sample, right? And if we select another random sample, then the sample mean or whatever other sample characteristics, right, will probably be a bit different. So then the question is, right, well, how different are these sample means from random sample to random sample? Um, One way you could do is to say, hey, let's go and keep collecting different random samples of the same size, find the sample means for each random sample, and then create a histogram of those sample means. Now, that's not the easiest thing to do, practically speaking, right? You're not going to go out and keep collecting data. Normally, what we do, right, is we just collect one random sample, and that's all we do. Now, the nice thing is statistical theory tells us that under some circumstances, the distribution of the sample means can be approximated by a normal distribution, right? So we know it can be approximated by a normal distribution. So we know that the values, right, the different values of the sample means, they will follow, if one were to plot them on the histogram, that they will follow a normal distribution, right, a bell-shaped curve. So we're going to use that idea to help us estimate features of the population. Right, we also know that with a larger sample size, the sample means will be closer to the population mean on average, and this is because, right, the standard deviation, right, of the sample means is given by sigma over square root of n. So if n increases, then the standard deviation of the sample means go down, which means that they are closer to the sample means are closer to one another. So right, in reality, right, so if you look at the calculations that we did in the last set of slides, we actually assumed we knew the values of the population mean and population standard deviation. Those values are not known in reality. So how are we going to use these ideas, right? So we don't know the true value of the population mean, but we will apply these facts, and specifically this idea over here that we know that the sample means will follow normal distribution. We use that fact to use the sample mean to estimate the population mean. So what are the typical goals of confidence intervals? To provide an estimate for the unknown parameter of interest, so population mean, as our example. It also provides a range of plausible values for the unknown parameter of interest. Usually we specify the estimate plus or minus some margin of error. So if you add and subtract the margin of error, that gives you a range, right, of the plausible values. Confidence intervals also provide a measure of uncertainty through the margin of error, right? So the smaller the margin of error, the smaller your uncertainty, right? The more certain you are of your result. Confidence intervals generally take the following form: estimates. So another word for estimate is statistic, right? So basically it could be the sample mean, it could be the sample slope, but we've been looking at the sample mean, right? So your estimate, your statistic plus or minus some margin of error, and we'll talk about how we calculate this margin of error. The margin of error reflects how precise we believe our estimate is, and is calculated based on a confidence level. So I have a few symbols over here. The confidence level that we usually use typically is 0.95 or 95%. There are a few ways of stating this confidence level. Some people write it as C. Some people use 1 minus alpha. Alpha, and we'll define this a little bit different, is called the significance level. And I'll define that in the next set of slides. So if you have 95% confidence, then your alpha is typically 0.05. Okay, so this is the framework, right? Then the question is, how do we actually calculate the margin of error? So a few terms over here. See, so these are just some definitions. So what do we mean by, say, 95% confidence? If we obtain many random samples of the same sample size and construct a confidence interval, each with 95% confidence, so I'm assuming 95% confidence, then 95% of these samples will have a confidence interval that contains the population mean. So that's a bit of a handful. I'm going to kind of try to illustrate what this means. So first statement, if we obtain many random samples of the same sample size, right? So perhaps you have your first sample, right? The mean could be, say, so let's talk about maybe a situation where we are taking data on number of hours of sleep per night for college students. So you have a first sample of, say, 500 students, college students, and the sample mean maybe 5.3 hours a night. And then you get another sample. Now the second random sample, even with a large sample size, is probably not going to be exactly 5.3, right? It could be maybe, say, 5.5, right? And then you take a third random sample, and the sample mean over here could be, say, 5.2 hours. Right, so this is the part where we say, suppose we take many random samples of the same sample size. So these all have the same sample size, and so on and so forth. Many of these random samples. And then for each sample, so let's assume that the margin of error in this example for all of these is, say, 0.2. And then we construct a confidence interval for each of these samples. So the confidence interval over here will be 5.3 plus or minus 0.2. So it will be between 5.1 and 5.5. Right? This confidence interval will be between 5.3, 5.7, and this confidence interval will be between 5.0 and 5.4, so on and so forth, right? So you have many of these intervals. What 95% confidence means is that 95% of these samples will have an interval that contains the true value of the population mean. So out of all these many different confidence intervals you have, 95% of these will contain the true value of the average number of hours of sleep in the population. Right? Not all of them will contain, right? So it could be an example where maybe the truth could be that the population mean is 5.47. Right? So 5.47 is inside this interval, so that's fine. It's also inside this interval, so that's fine. But for 5.47 is outside this third one, right? So it's outside of this. So if you keep doing this process of comparing the truth with each of these intervals, 95% of these intervals will contain the true value. Now we don't know what this true value is, so we cannot not know for sure which sample will have an interval that contains the truth, but we know 95% of them will. So that's what this statement is talking about, right? It's this idea of getting a different random samples, construct an interval, 95% of them, these intervals will contain the true. The key idea is because the sample means change, so the lower and upper bounds of the confidence intervals will change also. The next thing we talk about is the margin of error. So suppose we obtain many random samples, so same idea of the same sample size, and construct confidence interval with 95% confidence for each sample. The difference between the sample mean and the population mean in 95% of these samples will be no greater than the margin of error. So it's kind of a different way of stating this confidence level idea. So it's basically saying that the difference between each sample mean from the truth, right, will be no bigger than the margin of error for 95% of them. So in this first sample, the difference between 5.3 and 5.47 is indeed less. So that's the margin of error for this, right? So this estimate of 5.3 is within 0.2 of the truth. Same thing for the second sample. It's within 5.5 is within 0.2 of 5.47. The third sample, 5.2, is not right within 0.2 of 5.47. So right, this one's outside. The difference between 5.2 and the truth is larger than the margin of error. So we are saying if we're constructing these at 95% confidence, 95% of these sample means will be within 0.2 of the population mean. So that's what confidence level and margin of error is referred to. They actually refer to the same idea if you think about. Okay, so what is the actual formula for the confidence interval for the population mean? It's given by this equation over here. Sample mean, that's the estimate, plus or minus. So this whole chunk here is the margin of error. this value over here denotes what we call it's called the multiplier. It denotes the value of the standard normal distribution that corresponds to this percentile, right? So alpha is based on your confidence level. In a confidence interval, this is also called a multiplier, right? So generally speaking, right, the margin of error can be viewed as the multiplier times the standard deviation of the estimate. So the standard deviation of the estimate is this term over here. So generally speaking, right, we say that the confidence intervals estimate plus or minus margin of error. So in other ways that some people would say is the estimate plus or minus the multiplier times standard deviation of the estimate. Right? So different ways of expressing the same idea.